Hello viewers, in today's session we are going to discuss an important and conceptual problem from limits, and here we are going to find out the right hand limit and the left hand limit of this function f of x, that is equal to x square minus greatest integer of x divided by x plus greatest integer of x when x approaches to 0, right? So let us see how we can find out the right hand limit and the left hand limit of this function when x tends to 0, and then we'll also draw the conclusion whether the limit of this function f of x it exists at x tending to 0, right? So let us first find the right hand limit. So for a right hand limit, the notation is the limit, and here we have x tends to 0, and we put a positive sign here, and here we have f of x. So now for getting the right hand limit, we'll take x is equal to 0 plus h, where h is a positive quantity and it is infinitesimally very small. So here we have the real number line, x is equal to 0. So when we approach towards x is equal to 0, from the right of x is equal to 0, then we have a point in the right neighborhood of x is equal to 0, and this point is 0 plus h, right? And here when x tends to 0, then h also tends to 0. So now we can take x is equal to 0 plus h, that is simply h. So now we have limit when x tends to 0 positive, then we have h tending to 0, and here we have f of x is 0 plus h, that is h. So here we have f of h. So now we have limit h tends to 0, and f of h can be obtained by replacing x by h in this function. So we have h square minus greatest integer of h, then we have h plus greatest integer of h. Now see, here we have greatest integer of h, and this quantity h is infinitesimally very small, and it lies between 0 and 1. Here this h is very small, right? So h lies between 0 and 1, so the greatest integer of h should be equal to 0. So here we have 0, and here also we have 0, right? So we can now write limit h tends to 0, h square minus 0, and then we have h plus 0. So we have limit h tends to 0, h square over h, and limit h tends to 0, and here this h and this h get cancelled. So we have limit h tends to 0 h, and taking h is equal to 0, we have here a 0. So the right hand limit of this function when x approaches to 0 is equal to 0. So now let us find out the left hand limit. So now the notation for the left hand limit is the limit h tends to, here we have x tends to 0, and we put a negative sign here, and here we have f of x. So when we approach towards x is equal to 0 from the left of x is equal to 0, then we have a point in the left neighborhood, that is 0 minus h. So here we take x is equal to 0 minus h when x tends to 0, then h tends to 0. So x is equal to 0 minus h, that is equal to minus h, right? So now we can write the left hand limit as limit h tends to 0, and here we have f of x, x is minus h. So now we have limit h tends to 0, and f of minus h can be obtained by replacing x by minus h in this function. So we have minus h square, then we have greatest integer of minus h divided by minus h, and here we have greatest integer of minus h. So now we can write limit h tends to 0, minus h square is simply h square, and here we have greatest integer of minus h, and here we have minus h, and here we have plus greatest integer of minus h. So now we have to find out the value of greatest integer of minus h, as we have just seen that h is a positive quantity and it is very very small, that is it is infinitesimally very small. So h, it lies between 0 and 1. So when h lies between 0 and 1, then a minus h lies between minus 1 and 0. So this inequality can be obtained by multiplying this inequality by minus 1, right? So when h lies between 0 and 1, then minus h lies between minus 1 and 0, and by the definition of greatest integer function, anything lying between minus 1 and 0, the greatest integer of minus h should be equal to minus 1. So here we have for greatest integer of minus h, we can take minus 1. So now we have limit h tends to 0, h square minus, and here we have minus 1, and here we have minus h plus minus 1. So this is limit h tends to 0, h square plus 1. This is minus times minus is plus, and here we have minus h minus 1. So now this is a rational expression in h, and limit h tends to 0 can be obtained by taking h is equal to 0. So here we have 0 square plus 1, and here we have minus 0, and here we have minus 1. So this is simply 1. 0 square is 0 plus 1. This is simply minus 1. So this is 1 over minus 1, that is minus 1. So the left hand limit is equal to a minus 1. So viewers, from this discussion we have arrived at the result that when x approaches to 0, the right hand limit is equal to 0 and the left hand limit is equal to minus 1. And for the existence of the limit of a function at a given point, these two limits should be equal to each other, right? And moreover, right hand limit and the left hand limit both should exist, and they should be finite, right? So here the right hand limit and left hand limit both exist, and they are finite, but they are not equal to each other. So we can now claim that the limit of this function when x approaches to 0, the limit doesn't exist. So since 0 is not equal to minus 1, hence we can easily claim that the limit of this function when x approaches to 0, it doesn't exist.